Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Saffaanah Mubaarokah. I'm from 4B class of Mathematics Education and last my ID number is 073. Okay, in this occasion, we learn about power of a point. This is a very important topic in geometry. Isn't in the geometry module? So what is this topic all about? Suppose you have a circle. Let's call this circle gamma. And suppose you have a point somewhere in the plane. It could be on gamma, of course. Somewhere on the plane you have this point P. And you want to ask, what is the distance of P from the circle? It's kind of a fake equation because P has many distances from many points on the circle. So you can take several points on the circle and the distance of P from this point will be different. So how can you precisely define the distance of a point from a circle sort of intelligent? Define it. So this is how we traditionally do it. We try to draw a tangent from the point P to gamma. Of course, if P is inside the circle, that won't be possible. But for the moment, let's suppose it's outside the circle. And suppose this point is P, then Pt square. Pt square is supposed to tell you how far is the point P from the circle. How far point P from the circle gamma? How far is the point P from the circle gamma? And why is Pt square such a good candidate? To tell you the distance or give you a sense of how far is B from gamma, well, because if you draw any second from starting from P, so let's say PA B, this is a second, it's cutting through the circle. Then we can show that Pt square is equals to PA times PB. PA times PB, so this Pt square is actually a constant, a very strong constant given a point P and given a circle gamma. So if you draw any other second, let's say xy, then Pt square is also equals to Px times Py. You can do this with any secret. That's the magic. So whenever you do this product Px times Py, this much by that much is always square of the distance from the tangent point. Why is this quantity so nice? Because we can define it for points which are even inside the circle. So if we take a circle again, let's say gamma, and if I take a point P inside the circle and I draw a chord like this. Suppose this is A and this is B. Then PA times PB is again a constant from the point P for this fixed point. What does that mean? Well, it means that if you take any other chord passing through P, let's say xy, then this will be equal to Px times Py. So this particular product, this seems to be a constant for even points inside the circle of outside the circle. So that's awesome, because then we can use this value, this product, and say okay, let's suppose this tells us how far is the point P from this particular circle. So of course I made a lot of claims. I need to prove those claims. So the first claim that I made, claim 1, is that if I have a circle gamma, and if I have a point P outside it, then PT square is equals to PA times PV. So here is the claim. PT square is equal to PA times PV. This value is known as the power of the point P, so power of the point P with respect to the circle gamma. Okay, so why is this claim true? Okay, we can prove this way. Let's join. Okay, maybe I can use a different color. Let's join TA and TB. Let's join T and TB now. Notice that this angle is equal to this one. Why is this angle equal to that one? Well, we are using something called a tangent theorem. So we discuss this in a different video and also in our geometry modules all the time. It's a very powerful tool. What is so I won't explain that theorem here. I'll tell you the statement of the theorem. The theorem is this, that if you have a point P and if you draw a tangent like this, and if there is a chord TA, then the angle made by the chord with the tangent, so this angle is equal to angle made by this chord on the circumference. So chord to tangent angle is equal to the angle made by the chord on the circumference. Chord angle on circumference. So we use this all the time, this particular theorem. So we should definitely learn how to prove this. If you know how to prove this, why don't you put a proof in the comment? Let me see how you prove this theorem. Okay, so this angle is supposed that alpha, then this is alpha. Now what I'm going to do is I will be comparing the three angles P, TA and PTB, PT, and PTB. I'll be comparing these three angles, and I want to show that they are similar. I want to show that these three angles are similar. So notice that angle PTA is equal to angle PBT. So one angle is equal to another angle. Angle P is common, so angle TPA is equals to angle TPB, which is the same. Angle P, right, is so if two angles are equals, of course the third angle will be equal. So the three angles will be similar, so if they are similar. Now we can use proportionality of sides to complete this. So opposite to this angle, we have PA over PT. Opposite to this one is equal to. You have PB, so this total angle is here. This is equals to PD over PB. So you can cross multiply it to get PT square equals to PA times PB. PT square equals to P times B, and we are done. So that was the first climb. The second climb is that if I have a circle and if I have a point P, if I draw two chords like this, A, B, X, Y, then PA times PB is equal to PX times PY. This one is also quite simple. Just join these two and show that these two triangles are similar. This triangle is similar to this one, And the reason is very simple. These two angles are equal because they are subtended by the same chord. And these two angles are equal because they are vertically opposite triangles. And the remaining angles will obviously be same. So we can now use again the ratio of sides. So you have Py over Pb is equals to Ppa over Px. So if you cross multiply, you get Px times Py equals to Pa times Pb. That was the power of the point P with respect to the circle. So we learned how to compute power of a point with respect to a circle, and we have proved both the theorems that actually validate the formula. You can see more problems and concepts in geometry, and I hope you will be able to learn more. All the best for today. I'll see you in the next one, and take care. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om. See you next time.